¿qué tal? ¿Cómo están, amigos? Estamos muy contentos, gracias de que han participado en estas sesiones. Y en esta ocasión tenemos un invitado muy especial. Es una persona líder en investigación y en temas de control de miopía. Él es el doctor Paul Chamberlain, director de investigación y desarrollo para todas las líneas de programas de miopía en CooperVision. Él es autor y responsable de las principales publicaciones para nuestros estudios, como el caso de MiSight, y en esta ocasión invitado aquí, quien nos va a compartir su experiencia sobre este proyecto. Paul, bienvenido en América. Please go ahead.
Yeah, thanks, Ricardo. Good morning, everyone. It's my pleasure to be speaking to you this morning. And so my job today is to tell you the whole story of the MiSight one-day clinical study. That's a 7-year clinical study. And you might be asking yourself, how on earth are we going to tell a story of 7 years in 35, 40 minutes? And the answer is, I don't know, but I'll do my best. So let's get cracking. Okay, to start off with then, I should probably explain how this MiSight one-day clinical trial study design works, because across the 7 years, we split this study into 3 distinct parts, and each part of the study has a slightly different objective because of the study design we have. So let's start on the left-hand side and we'll walk through it step by step. So the part 1 is the original clinical trial that we designed to test fully the MiSight one-day contact lens. What we did in part 1 is we took a large group of children, 144 in all. They were all aged between 8 and 12 at the beginning of the study. None of them had ever worn contact lenses before, and that might be quite important to remember for later. And as you'd expect for a clinical trial of this magnitude, all of the usual controls were in place. So we randomized them. We didn't let them decide which treatment they were in. We didn't tell them, or the parents, or the investigators, which treatment they were in. And so you've got 2 groups going side by side. They're well matched. They're similar ages. They're similar genders. They're similar ethnicities, similar prescriptions to start off with. And they either wear MiSight one day in both eyes for 3 years, or in the other group, ProClear one day, which is exactly the same contact lens, but without the special treatment, for 3 years in parallel. And what we're doing in that part 1 is we're looking at the differences in myopia progression. So that's spherical equivalent. So the change in prescription or the change in axial length between the 2 populations. And at the end of that, we get a measure of myopia control. So at the end of part 1, we then wanted to pivot to part 2. And I can remember when we were about to start to part 2, that all of the investigators and the people running the study says, no way can you continue with the control group for another 3 years. The effect of MiSight is so obvious. We think it will be unethical to continue the children in a placebo or untreatment group for another 3 years. So we had to make the decision then to switch now the ProClear one-day group into MiSight one day. You can see that in the middle panel just here. And we continued the original test group in the MiSight one day as well. Now, whereas the first part of the study, no one knew what they were wearing, we decided as both groups were in the same lens that we would make this open label. And we followed them for another 3 years. I'll spend a lot of my presentation today on this part of the study, because there's a lot of interesting things that we learned, I think, about myopia control in general, and particularly about MiSight in that part. And then fast forward another 3 years. So the children were average age 13, between 11 to 15 at part 2, and then we'll work for another 3 years. And then now they're between 14 to 18, average age 16. Part 3, what did we do in part 3? Well, we tried to explore a question that's on a lot of people's minds, I think, with myopia control, which is what happens to the children's eyes if we take them out of a treatment lens and we put them back into a regular contact lens. And again, we'll cover that at the end of the presentation as well. Okay, so let's go forward. And as I said, I'll spend much of my time on part 2, but let's have a quick recap of part 1. Probably many of you have seen these results before. They've been presented for a number of years now. And so remember, this is a straight comparison between the groups wearing MiSight one day and the groups wearing ProClear one day. And we're comparing or looking at the difference in myopia progression. I'll show you some slides a little bit later, but the headlines are that in that first part of the study, we saw a 59% reduction in myopia progression and a 52% reduction in axial lens growth in the MiSight group. What that means, and you'll see it in a later slide, is basically the group of children on average wearing MiSight, their eyes grew less than half of the rate of the untreated regular control group. And another really interesting statistic that we used a lot when we were speaking to the FDA to try and get approval for MiSight one day is I looked at the number of eyes that didn't progress. Now, I defined no progression as if spherical equivalent, so sphere plus half cil, is less than minus 0.25, that's not even one click of the phoropter. And so if it's not even one click of the phoropter, I'm not changing their prescription. Across the full 3 years, 41%, nearly half of the eyes had no change across the whole 3 years, which I think is a really good message to be able to tell parents when they're asking what the expectations might be of this treatment. So that's a little bit of a recap on part one. And of course, this results were pretty pivotal in the field. And, you know, we're really proud of what happened next. And of course, some of the major things that what happened next was that we used this part one data to be the first ever device to have an indication from the FDA for the slowing of myopia progression in children. And it's still the only contact lens or device that has an actual FDA indication for the treatment or slowing of myopia progression. Following on from that, we also then, just a couple of years ago or 18 months ago, got approval for the same or similar indication in China. And again, that's the first product to have such an indication in China, which is such an important area with such high myopia levels there. And we're rightly quite proud of these regulatory approvals, and we believe strongly that we should do things the right way and give parents proper information by getting the appropriate regulatory approvals for this product. So let's switch gears now and look at part two. So as I alluded to a couple of slides ago, we now have an interesting design. I've called it a switch treatment study design, because you can see in part two, at the top there, the control group is now switched into MiSight one day, and the test group has stayed in MiSight one day for the full 6 years. Now, it's sometimes a little bit confusing to tell which group is which, because they're both now in the same contact lens. So to make it a little bit easier, the group that started in ProClear one day and then ended up in part two in MiSight, in the end, they were treated for 3 years of part two in MiSight one day. So because they were treated for 3 years, we're going to call them the T3 group. And then, of course, the original MiSight group have now had 6 years of treatment in MiSight one day by the end of the part two. So we will call those the T6 group, and I'll use those names rather than test and control from here on. And so on one side, you see that when you have a study design like this with part one and part two, and in part two, both groups are in the same lens, you might think, well, this is a little bit disappointing now because you won't be able to say what is the myopia control because you no longer have a control group. And that's certainly true. And I think I explained the reasons why, and I think they're good ones for switching the placebo group into MiSight rather than denying them treatment for another 3 years. But actually, as we dug into this study design, we realized that we could use this unique study design to answer some of the big questions in myopia control. And these are the questions I'm going to try and answer for you in the next half an hour. So let's go through these one by one. So number one, will slowed myopia progression sustain across multiple years? Again, you know, for lots of people have been working in the area of myopia control for many years, but of course this was, you know, one of the longest studies at that time, and certainly is still now, but there was still relatively little clinical information about the longevity of myopia control interventions. And I'm sure all of you listening to this aren't interested in getting into myopia control just to treat a child for 1 year or 6 months or 18 months. You're thinking that you're going to treat these children for the entirety of when their myopia progression is continuing. So this question number one is critical for the field, which is, will the slowed myopia progression that we clearly saw in part one sustain across multiple years? Well, we have an opportunity now to look at 6 years worth of data. So that's Big question in myopia control, number one. Number two is that having switched the Proclear group at the end of part one into MiSight, remember that group is now 11 to 15, whereas the original group were 8 to 12 back here. And so an older cohort, will MiSight one day still work if we treat or start treatment at an older age? And so this comparison between Proclear switching to MiSight allows us to pick at that question as, will we get an effect if we treat an older cohort? Now, observant ones among you will say, well, yes, but this group will be older than the Proclear group, and so you would also expect some sort of slowed myopia progression, and that is absolutely correct, and that is a major covariate in this analysis and analysis number one, but I think you'll see when I go through it that we can account for most of that age effect. And big question myopia control number three. I hear often that people worry that the longer you treat a child in the same myopia control product, the less successful it will be, that maybe the effect will start wearing off, maybe the eye or the brain will adapt to the treatment. Well, what do we have here in comparison number three? We have two groups that, remember from the very beginning, they are exactly the same age, they are exactly the same ethnicity. Obviously the T3 cohort has more myopia. The only difference is that in the bottom panel, T3, they're in years 1, 2, and 3 of treatment, so right at the beginning. The MiSight one-day T6 cohort are in years 4, 5, and 6. And so if the treatment is going to wear off, then maybe we will see faster progression in the T6 group than the T3 who are new to treatment. So we'll look at that question as well in this analysis. So let's start. Okay, so here we have progression in refractive error. And so a typical scale here, this is the average progression for the entire population. The orange is for the T3 group. Remember, they were in Proclear one day at this point. And the purple is the MiSight one day group. And the more myopia progression, the more minus you progress on average, the further down the y-axis you'll be. And so here you can see the difference between the purple and yellow at the end of 36 months or end of part one was 59%. That was the effect I showed you on the first scale, and on the first slide, I should say. And now we're going to move into part two. Now, you can see also that I've actually put the data year by year by year. And this was to try and give you all an insight of the rate of progression that we see in each year. And you can see a little bit of the age effect actually from the T3 group. They went from 0.58, a bit slower in year two as they get older, 0.36, and then 0.30. And then for the MiSight group, 0.18, 0.17, 0.16, very consistent. Let's see what happens when they go further into years 4, 5, and 6 of part two. So if you look at the T6 group there, again, you see each year a really similar progression rate. So we had this 59% slowing with the 0.18, 0.17, 0.16, and this slowed rate continues in that group, 0.18, 0.17, 0.06 diopters. We think that this shallowing here, of course, is because by year 6, many of the children are over 18, and maybe it's brought the average more shallow because they've stopped progressing completely, which is fantastic, of course. When we look at the T3 group, we've gone from no treatment to treatment, and we see a big change there, 0.30 to 0.13, more than we would expect for aging, and then 0.17, 0.01. And then also look between these two groups. Remember, they're the same age, they're the same ethnicity. Obviously, the T3 group is more myopic, as you can see here, but these lines are almost exactly parallel. They're progressing the same. They're the same age, and they're in the same treatment now, and they seem to be getting a very similar effect. Moving on to axial length. So again, whenever you're looking at myopia control data, you would hope that the axial length data is a mirror image of the spherical equivalent, because the prescription or the spherical equivalent should be changing as a function of the eye growing. And we see exactly that here. So again, the T3 group, when they were untreated in the Proclear group, 0.24, 0.22, 0.16. And then, as I said right at the beginning of the presentation, the MiSight group or the T6 group progressed at about half the rate in part one. So this is what got us the FDA approval, 0.09, 0.11, 0.10, half the rate of progression through that part 1. So again, these groups are switched both into MiSight. So we want to see sustained slowed growth in the T6 group. We want to see slower growth in the T3, and hopefully we see similar growth between the two groups. And that's exactly what happens. And so if we look at the T6 group, first of all, you can see we start to see that they get a bit slower actually from part 1, as we would expect, because they're 3 years older, 0.07, 0.07, 0.05 through those 3 years. So now we have 6 years of eye growth data for this big population, showing that this slowed eye growth has sustained. In fact, if you look at the total amount of growth of the T6 group here, that only now, not just about at the level that the control group had already grown after 2 years. So we've gained, if you like, 4 years worth of eye growth in the T6 group. Looking at the T3, we introduced treatment here at the end of the 3 years, and you can see you saw an instant slowing there, and again, almost parallel to the T6 group. They're the same age, and they're now in the same treatment. This is year 4 data, this is year 1 data. It seems exactly the same progression. And so now I'm going to try and show you some of the statistics we use to try and prove those 3 big questions in myopia control that I showed you a few slides ago. So this is now on this chart. Well, I'm only doing the axial length because the data is a bit cleaner, and it's always a bit more consistent data with axial length. And so here we have basically the part 1 comparison. This was the original part 1. 52% slowing, and of course you can see that the comparison between the test T6 group and then the control group T3 in part 1 was statistically significant. On the x-axis it's 3 years, and of course both parts are 3 years long, so I'm going to put every part in this one panel. So that's the part 1 effect. But what was our big questions? Question number 1 was, will myopia control effect, will that slowed eye growth that we observed in part 1 sustain across multiple years? Remember, we want confidence that this slowed eye growth won't just work for a few years. We want it to work across childhood. So here is again the control group in part 1 and the test group in part 1, the T6 group. We're now going to try and look at the T6 group in part 2, and I'm going to lay them on the top of each other so we can compare like to like. And here they are. So actually, yes, as we would expect, they're a bit older, but that same population in part 2 was a slightly slower eye growth, but it wasn't statistically significant. But we can see evidence here that there is no difference. There's no acceleration of eye growth. And so the slowed eye growth we can say is sustained across years 1 to 3 and years 4 to 6. It seems to be very similar eye growth across both parts of the study. So yes, we've a sustained eye growth, slowed eye growth across multiple years. What was the second question? It was, if we can slow progression if we're coming to treatment late. And many of you will see children in practice with progressing myopia that aren't within the 8 to 12 indication. They're much older than that. Are we too late? Should we not even try? Or will we see some evidence that we can achieve slow progression in this older cohort? Well, let's have a look. So here's the T3 group when they were untreated and 3 years younger. We'll always remember the age difference. And so now I'm going to show you the T3 group after we've introduced treatment. And we would, of course, expect it to be below the orange line because they are a little bit older in part 2. So let's see what we found. But we see quite a large reduction in eye growth, whereas they progressed by 0.62 millimeters in part 1, just under 0.2 millimeters. I think we see plenty of evidence of considerably slowed eye growth when we introduced the MiSight lens to this T3 group when they were average age 13 rather than average age 10 at the beginning of part 1. So yes, we achieved slow progression in that older cohort. What was question number 3? Remember, I was saying that we hear sometimes that maybe the treatment wears off, that maybe the eye or the brain adapts to the signal from a contact lens and the children will not get as good a treatment in later years. Well, remember, the T6 group have now been in treatment for years 4, 5, and 6, and T3, 1, 2, and 3. So if the treatment is wearing off, then surely we should see much faster progression in the T6 group in years 4, 5, and 6, and in the T3 group who are the same age in years 1, 2, and 3. But we don't see that. You see the error bars are totally overlapping here, and so there's absolutely no statistical difference. We don't see any evidence of prior treatment on average resulting in faster progression across our population. So in summary, when we had these big questions in myopia control, because no one had gone this far before in a myopia control study, we had the questions, will myopia control sustain across multiple years? And I think we've shown evidence that it has. Will slowed progression be achieved when we treat an older population than we did originally? And I think, again, we've presented evidence that that is indeed the case. And did we find any evidence in the T6 group with faster progression in later years that the treatment is wearing off somehow? Will the fact that they're in later years of progression give them a disadvantage versus new people? And again, we don't really see evidence that the prior treatment resulted in faster progression in part 2 for the MiSight one day. So these are really important questions, I think, for us as we, embark in this still relatively new field of myopia control, that we can have the confidence that we're getting more and more information about how these treatments like MiSight one day work. I wanted to show you another little analysis that we did. You might remember from, I think, the second slide that I said that 41% of children had not even 0.25 spherical equivalent progression in the first 3 years of the study. So again, we're interested in what's happening long term. We're in this for the long game when we treat our children. So I thought it'd be quite interesting to show how many proportion of the eyes in that original treatment group still hadn't changed after 6 years. And so the answer is 23%. Nearly a quarter of the eyes that started the study showed no significant change in spherical equivalent across the entire 6 years of the study. So 1 in 4 eyes were completely stable through the 6 years. I think that's an amazing result and a really encouraging one to be able to say to parents, well, we can't predict the future, but we know that in a long-term clinical study, 1 in 4 eyes were refractively stable across 6 years. And that could give parents a lot of confidence before they start a MiSight one day treatment. If you're interested in the results I've just presented, and actually some of the things that I don't quite have time to present in today's, please feel free to download our paper where most of this data comes from. If you scan the QR code on the top right of your screen here, this paper is a free download, and you'll see most of the data I presented and a bit more as well. So I'll give you a second to scan that if you wish, and then before we move forward to some more results that we've seen in part 3. But before I do that, and there's another QR code for another paper here, and so this is a different link because we didn't have room to put it in the original paper. Of course, we talk a lot about the longevity of this study, and really, it's very exciting to talk about the myopia control aspects of this product. But there's also another aspect, and it's been well talked about that this is probably the longest running clinical study ever conducted so far, at least in children. And actually, it's probably one of the longest running consecutive studies in contact lens wear at all. And so when you're doing a study of this size, and we have aftercare visits quite frequent at the beginning, and then every 6 months through 6 years, we have gathered an enormous amount of data about ocular health in contact lenses. And these kids were not wearing the contact lenses part-time. I don't have time to show you that data, but basically the average wearing time was something like 6.5 days a week, 13 hours a day by the end of the study. These kids were wearing these lenses full-time. And so if anything's going to happen to their eyes, it's going to be with that sort of wear. And so and obviously we had to do this for the FDA and for China, and basically get into lots of detail about the ocular health results across this 6-year period, because we are now asking children to wear contact lenses full time. And the results are pretty fantastic, I think. It shows you actually that we should trust the children to be able to handle contact lenses well, because the results of the eyes were incredibly encouraging. We only had one, in any clinical study, you always have to report adverse events of any time. Even if the child falls off a swing and breaks their arm, that is an adverse event while they're in the study, even if it had nothing to do with contact lenses. And so every adverse event is reported. And there was only one serious adverse event, that was a uveitis related to herpes zoster. We had two significant events. This is across 653 wearing years, remember. That was scars that children presented asymptomatic, and only 4 non-significant infiltrative events. Now, I've done a lot of contact lens studies in my career, and I would see more events than this, maybe in much shorter study in adults than this. 40 events across only 30 of the 144 subjects had some adverse events. And of course, adverse events are more serious, but thankfully rarer situations. Something that you all may face in the practice is seeing maybe unusual or unwanted findings when you're looking through the slit lamp. Well, again, in a clinical study, we need to look at and carefully grade a number of different categories in the slit lamp every single visit, every single eye, every single child. And we're looking at limbal hyperemia, bulbar hyperemia, corneal staining, palpebral roughness. We're flipping the lids every visit and looking at these eyes. And every time we see that, we're grading it as 0, nothing's happening, 1 trace, 2 mild, 3 moderate, and 4 severe. And usually in the training for a protocol like this, we're telling the investigators, if you're seeing a 3 or a 4, it doesn't necessarily mean an adverse event, but maybe you want to take the contact lenses out for a day, maybe you want to give some eye drops or something like that. And so across the 6 years of the study, we calculated that an investigator did 26,137 slit lamp observations across those 6 years. And of those 26,000 observations, 99% of them were grade 1 or less. The eyes were perfectly clear, no problems at all in 99% of the time. And I said that maybe we'll do something if we see something greater than 2. Well, out of those 26,000 observations, only 5 times did an investigator grade any of those findings there, limbal, bulbar, corneal, greater than grade 2, 5 times out of 26,000. So this is really encouraging that these children are looking after their eyes are responding well to full-time contact lens wear. Hopefully, you might be looking forward to very boring slit lamp examinations going forward when you treat these children with MiSight one day. It's a really good finding, I think, about contact lens wear in general, not just about the myopia control. Okay, so for the last 10 minutes, let's move forward into part 3. So by the end of part 2, we ended up with 85 subjects still in the study. And then through part 3, we asked them to enroll to stop treatment. And so in order to stop treatment, we gave them exactly the same contact lens, which ProClear One Day is, but without the MiSight rings, without the MiSight treatment. And at the end of the part 3, we ended up only losing 7 patients. Now, considering that we were telling all these patients that we were taking them out of treatment because they had to sign a new consent form each time here, to only lose 7 people in part 3 in the middle of the pandemic, we were pretty pleased about that. And so nearly 80 subjects, 160 eyes, plenty of data to get an idea of what we see happening at the end of treatment. And again, this is a good way of looking at the potential effects of taking a child out of treatment. I've seen plenty of studies where maybe the child has been treated for a year and then taken out, or 2 years and then taken out. Well, that's not really what's going to happen in real life. I don't think that many of you are entering into the treatment to treat a child in MiSight One Day for a year and then say, right, we've done that now, we'll take you out and see what happens. So it's not really a realistic assessment of the potential eye growth after treatment has finished. Whereas actually taking them out after 3 or 6 years, well, maybe it's not exactly the amount. Maybe in practice in the future, it'll be 10 years or more that you'll be taking them out, but at least it gives us a much better, more real world assessment of what happens when we take someone out of these treatment lenses. And of course, the big question for most people is, do we see a rebound effect? Well, of course, when we were looking at this study, we had to ask ourselves, well, what even is a rebound effect anyway? How much effect is that? Right, so we've got children whose myopia progressing. This is a model, this isn't the actual data, but I'm just doing a mock-up here to try and explain it. Even these eyes are still growing and they're under treatment. So we need to expect some growth. So how much growth is too much growth? And so we started to speculate at the beginning of this part 3 as to what the different findings might be. And so we speculated that the so-called rebound effect is going to be an amount of growth that we would think is greater than what we would expect for an untreated child of that age. In this scenario, the treatment effect that you've gained in the previous 6 years in this example is almost immediately being lost as soon as you take them out of lenses. In fact, this growth again, this is just a mock-up, this growth is at the level of the control population when they're much lower. We think that rebound is not going to be increased eye growth because they're not treated. So of course you're going to see an increase in eye growth, you would think. So it needs to be something at the level of when they were much younger. We might see something like a return to age normal myopic eye growth. So there's no further treatment effect, but you're not losing any of that gain. And you can see in this mock-up here that this orange line is exactly parallel to this imaginary control group here. They're the same age, and it's saying, well, prior treatment doesn't matter. They'll return to the same level because they're basically untreated. Now, you'll know, of course, that we have already not enabled us to do this because we don't have an untreated control group running in parallel. But I'll try and explain how we try to look at that. Or wouldn't this be a fantastic result? Maybe somehow the treatment effect has been locked in. We've taught the eyes how to grow slower, and the eyes now have some kind of memory, and the treatment effect continues even though they're no longer in treatment. And so now we're imagining that we'll see some sort of an effect where the growth in year 7 is no greater than what we see in year 6 or year 5 and so on and so forth. In fact, maybe it's even slower because they're older. So that would be a situation of sustained eye growth. And so to try and answer these questions, we compared the results that we actually saw to eye growth in the same population when they were untreated and younger, because if it's faster than that, that's definitely rebound. And we're going to try and compare eye growth to the treated group when they were in previous years to see if the treatment effect is sustained. We have no comparison control group to really answer this question of age normal myopic eye growth, but maybe we can get a clue. So these were the sort of results that we were looking for when we started to look at part 3 results. And also, of course, one more thing is that we have two situations. We have a group coming out of treatment who've been in treatment for 6 years, and a group coming out of treatment that have been in treatment for 3 years. Do we see any different eye growth from those different treatment durations? Is it better to treat shorter? Will we see the 6-year group will accelerate more than the 3-year group? And we can compare between the two groups as well. So again, like in part 2, there's a lot of questions we can answer by looking at this part 3 data. And here is the data. Now you can see now that the numbers look a little bit different to when we showed you in part 2, and that's because I'm only analyzing the data for the eyes that actually finished the study. Okay, obviously I can't go backwards in time or forwards in time for eyes that have discontinued the study. But let's have a look here at we saw the progression in part 2, and we can see that we progressed in 0.17 in the T6 group when they're back in proclear, and 0.22 diopters, this is the refractive error, in the T3 group. And you can see here actually there's quite a lot of variation. You always get a bit more noisier with the spherical equivalent. So let's now move forward to the axial length data. And again, you can see that this is a bit flatter, it's a bit more consistent. And again, let's have a look here. So here's the T3 group, 0.05, 0.07, 0.07, and then 0.09 when we took them out of treatment, 0.07, 0.07, 0.09 for the T6 group, and 0.10. So let's have a look at what this data might mean. Well, first of all, you can see that these two lines are absolutely parallel. So the last question I posed, will the number of years of treatment have an influence on the growth rate when we take them out of treatment? Well, these two lines look exactly parallel, so I don't think we've got any evidence of this. Remember what we were looking at in terms of if we're seeing acceleration or so-called rebound, then we would expect to see this eye growth match that of the kids when they were younger and untreated. Well, 0.09 is nowhere near being faster than 0.25, 0.22, or 0.16. So I think we can be pretty sure that we see no evidence of rebound. These are not, I would expect to be seeing numbers like 0.25 or 0.26 if we were getting rebound. That is fantastic news. We have taken these children out of 6 years of treatment and we are not seeing any signs of acceleration. It looks like the treatment effect is locked in. Do we see any signs that it's returning to age normal myopic eye growth? Well, we would have expected this orange line, if the treatment effect was still working, to be exactly the same, maybe, as the 0.07, or maybe even slightly shallower. The statistics can't tell us if this is age normal myopic eye growth, but it's certainly not a rebound. And just to remind everyone here, here's the model we said. This would be what rebound looks like. This is what age normal myopic eye growth, and this is what sustained effect, and this is what we actually saw. So in conclusion, we said that the results did not meet the criteria for rebound. We saw no evidence of, in fact, the eye growth was statistically slower than what we saw in part 1. We didn't quite meet the criteria for sustained treatment. These progression rates here were statistically faster than in part 2, so we couldn't prove that the treatment was sustained. We also managed to prove that it didn't seem that we saw any difference between the T3 and T6 groups, so the number of years of prior progression didn't seem to influence the speed of growth when we took them out of treatment. And the one thing that does come out through all of these analyses I've showed you in the last 40 minutes is age seems to be a very important factor. And as I said, we cannot confirm that these eye growths are returning to age normal growth, but it's possible that that is exactly what we're seeing in part 3. And we're doing some more statistics you maybe see in the future to try and prove that this is age normal myopic eye growth. So that takes us to the end of this 7-year story. It's a lot of information in 40 minutes. So if you kept up, well done. I've been living this data for a long time, and so it takes me many years to go through it all. But let's a bit of a catch up. We saw that MiSight in part 1 showed a clinically significant effect. We saw sustained slowing in part 2, and we saw no evidence of rebound, and we gained and maintained the accrued treatment benefits in part 3. So I hope you enjoyed listening to the one-day clinical story, and thanks for your attention.